So aside from proving each of these formulas, which can be done in our exercises in the textbook, and we'll talk about those in class, how would we evaluate some of these other things? Well, all right, let's talk about tangent of 13 pi over 12. We're going to use one of these formulas right here, and we could probably use one of these two tangent formulas over here on the bottom. Let's see about that. How would 13 pi over 12 be divided up? Well, it looks like this is the kind of angle that would come about by having denominators of 4 and 3. So we could either divide it up as a sum or a difference of two angles. I'll tell you what I did. In my evaluation, I treated 13 pi over 12 as the kind of fraction that could be divided up as two fractions over 12 that could be reduced. So let's look at it as a subtraction of two things here. What over 12 minus what over 12? Well, 15 and 12 do have common factors, so if I made it 15, I could subtract from it 2 and get 13. And what is these reduced to? Well, 15 pi over 12 is the same thing if we divide both the numerator and denominator by 3 as 5 pi over 4, which is one of the special angles that we definitely know, and 2 pi over 12, that reduces as pi over 6. So we could treat this using our difference formula for tangent all the way down here at the bottom. So let's do that. We're going to treat this as the tangent of the quantity 5 pi over 4 minus pi over 6. So let's use our formula right here. What does it say? It says because we're taking a subtraction, we're going to have a fraction. And in the numerator, we'll be taking the tangent of 5 pi over 4 and subtracting from it the tangent of pi over 6. And in the denominator, we'll be taking 1 plus the product of the tangent of 5 pi over 4 times the tangent of pi over 6. Okay, so it's time for us to go back to those basic values. If I wanted to find the tangent of 5 pi over 4, I will note 5 pi over 4 is an angle that is in the third quadrant. Because in the third quadrant, here's pi, 5 pi over 4 is a little bit larger than that, right? 5 pi over 4 is larger than pi. And pi is equal to 4 pi over 4, so if we take the difference between these two, our reference angle here is pi over 4, and in the third quadrant, we know the tangent is a positive value, and the tangent of pi over 4 is equal to 1. So our expression becomes 1 minus tangent of pi over 6. Well, tangent of pi over 6, that's one of our basic values. For tangent of pi over 6, we would have had radical 3 over 3. In the denominator, we're going to have 1 plus 1 tangent of 5 pi over 4 times the pi over 3, so 1 plus square root of 3 over 3. And now you're thinking to yourself, oh boy. Okay, so now we've got fractions that involve radicals. And that's right, it means we're going to have to simplify this expression. If you've got a fraction within a fraction, first of all, we can simplify by multiplying both the numerator and denominator by the LCD. In this case, that's 3. So if I do that, I get a new fraction, 3 minus the square root of 3, divided by 3 plus the square root of 3, canceling out that denominator of 3 from both fractions. Now, if you don't remember this part, whenever we had a fraction that had a sum or difference in the denominator, and it was a radical, we multiplied by the conjugate of the denominator to rationalize. So we would multiply in the numerator denominator again, this time by 3 minus the square root of 3. So we're going to multiply that in the numerator and the denominator. It's just multiplying by some clever form of 1. in order to reduce that fraction. Well, here we go. That means we're going to have to do 2 multiplications. In the denominator, it's not bad because we're taking a sum and difference binomial, and that becomes the square of the first term minus the square of the second term. But in the numerator, we might have to distribute a little bit right here. So we're going to take 3 times 3, which is 9, minus 3 times the square root of 3 minus 3 times the square root of 3. So that's going to be minus 6 times the square root of 3. Minus square root of 3 times minus square root of 3, that's plus 3. Let's simplify this a little bit more. By adding our like terms in the numerator, we're going to get 12 minus 6 times the square root of 3. And in the denominator, 9 minus 3 is 6. So we can reduce this fraction, luckily, one more time. There's a common factor of 6 to both terms in the numerator. It becomes 6 times 2 minus the square root of 3 divided by 6. And so our reduced expression becomes 2 minus the square root of 3. There we go. There's a good one, huh? Okay, one more here. Let's talk about this cosecant of 105. What do I do with that? That's not one of our formulas. Well, the answer to this is that we're going to have to rewrite by using one of the formulas that we do know. So in this case, let's make 105 something that's useful to us. 105, what is that? Well, it could be the same thing as saying 60 degrees added to 45 degrees, both of which are special angles that we do happen to know. So let's see what's going to happen right here. If I wanted to find the cosecant of 60 plus 45 degrees, I really want to evaluate 1 over the sine of that sum, 1 over the sine of 60 degrees plus 45 degrees. So that means I'm going to use my formula for the sum of 2 angles using sine. That's going to give us 1 over the sine of 60 degrees times the cosine of 45 degrees. This is beginning to look familiar. Plus the cosine of 60 degrees times the cosine, times the sine, times the sine of 45 degrees. Well, very interesting. Let's go ahead and put the numbers in that we would get right here. So remembering this is still part of a fraction, we're going to have 1 over. The quantity for sine of 60 degrees is radical 3 over 2. For cosine of 45, it's square root of 2 over 2. Plus the cosine of 60 degrees is 1/2. And the sine of 45 degrees is square root of 2 over 2. And we did this in a previous example. We found that that was really the same thing as saying the square root of 6 plus the square root of 2 all over 4. But since this is now part of a fraction, we're going to have to do a little bit more work. We invert and multiply our denominator fraction, so we have 4 divided by the square root of 6 plus the square root of 2. And just as we did up here in this first example, we're going to have to do a little rationalizing of our denominator. So that means multiplying by the difference, the conjugate of the denominator, square root of 6 minus the square root of 2. So we're going to have to multiply that into the numerator and denominator equally. Doing so gives us 4 times the quantity square root of 6 minus the square root of 2 divided by, we're multiplying conjugates, square root of 6 times square root of 6, that's 6. There's no middle term, minus square root of 2 times square root of 2, that's 2. One more reduction gives us 4 times the quantity square root of 6 minus the square root of 2. You'll notice I'm not distributing in the numerator. I wouldn't do that until the very end. Divided by 4. And there's no need to distribute because the 4 cancels, and we're left with the expression square root of 6 minus the square root of 2. So that is the value that we seek in that particular example. Okay, just a little bit more to go.